So as we know, till yesterday's class, we studied physical properties of metals, like chemical properties of metals, I think almost reaction with the salt solutions, reaction with the strong alkalis. After that, in yesterday's class, we studied metal activity series. So still yesterday, I asked somebody, they don't know what is metal activity series. So metal activity series is very important. And today's after this class, I will send you the 8th class book. In that, you learn what is the importance of why hydrogen is included in the metal activity series. Now let us see that we have studied that metals means, just have a glance, metals means whose valency. Valency is how much, guys? Everybody? Whose
One,
valency
two,
is 1, 2, or 3. And of course, valence electrons also how much? Valence electrons also 1, 2, or 3. So they are called as metals. So whose valence electrons are either 1, 2, 3 or valency is 1, 2, 3, they are called as metals. So these metals always they will lose the electrons and they will turn into what, guys? By losing electrons, they will turn into positive ions. That is only called as what? Cations. So that is why they are called as metals. They are called as electropositive elements. Am I right or wrong? Everybody? So electropositive elements we used to say. So coming to the non-metals, keep in mind, of course, we will again study basically valence electrons. For your purpose only I'm saying. So valence electrons, basic and valency. So observe very carefully. Valence electron starts from like this 1, 2, 3, 4, 5, 6, 7, 8. Okay. Valency. If one valence electron, valence is also 1. Two valence electron, valence is also 2. Three valence electron, valence is also 3. Four valence electrons, valency is 4. If it is 5 valence electron, valency becomes 8 minus 5, which equals how much, guys? 3. If it is 6 valence electrons, 8 minus 6 valency is 2. 7 valence electrons, 8 minus 7 valency is 1. 8 valence electrons, 8 minus 8 valency is how much, guys? Valency is how much? Everybody?
0.
0. So this is what we used to call as noble gases or inert gases. And 4 is for 4 and 4, we used to say they are metals also, non-metals also. So forget about the 4. 4 is always neither positive nor, everybody, neither positive nor negative. So this is alone actually. This 4 and 4 only chemical compound will form by sharing of electrons. NID, everybody? By sharing of electrons. Okay, ma? This 1, 2, 3, this is by loss of electrons. That is what we used to call as donating electrons. Clear, all of you? And this one, 5, 6, 7, that is what 3, 2, 1. This one is gain of electrons. So this is what the picture always has to remember in mind. Donating electrons 1, 2, 3. 4 sharing of electrons. Next 5, 6, 8. Sorry, 5, 6, 7. They are gain of electrons. So this is the only ways to call 5, 6, 7 only. Of course, 4 also we can say non-metals. 4, 5, 6, 7. But 4 like metalloids also having that. That's why 4 you avoid it. So valency of non-metals. How much, guys? Everybody? Valency of non-metals is how much? Valence electrons is 5, 6, 7. Valency is how much, Ra? 3 to 1. Understand, all of you? So that is what. Basically, we can say they are having 5 to 4 to 7 valence electrons. That is what we used to call as non-metals. So these 7 electrons we used to call something. Even last previous 2 classes we are studying that. Those elements who is having 7 valence electrons, we used to call something. Anybody? Yes, please. I told you learn the we used to call as halogen. What is the examples of halogens? Fluorine, chlorine, bromine, and iodine. Very, very important one. So like alkali metals. Alkali metals means what? This is alkali metals. So like alkali metals, halogens also highly reactive non-metals. Alkali metals, highly reactive. Alkali halogens, highly reactive. So this is what is about it. Alkali metals, valency is 1. Halogens also, valency is 1. But here, alkali metals, valence electrons is 1. Halogens, valence electrons are 7. They can lose 1 electron, and this one, they can gain 1 electron. Yesterday we studied reason for different reactivity of metals. Am I right, everybody? Why some metals react faster, some metals react slower? Because of valency. Am I right or wrong? That is what? Tendency to lose the electron or tendency to gain the electron. That is only makes the metal react faster. Is it okay, everybody? Please respond, all of you. So that is what. So as metals, they will lose the electrons and they are called as electropositive or electronegative, everybody. Electropositive is to called as. Same way, these non-metals, they will gain the electrons. That is why we used to call them as, what we used to call, guys? Respond, Ra. Electronegative elements.
Negative ions.
Yeah, negative elements. Okay. So they gain or share electrons, both. They gain electrons or they will share electrons. Okay. To complete the rule. 9th class you studied. Anybody can tell what is that rule? Octet. And they act as, see, metals are strong reducing agents. Then non-metals are what? And act as non-metals are what? Everybody. They are
Oxidation.
yes, oxidizing agents. Keep it in mind, metals are reducing agents and non-metals are what? Everybody? Oxidizing agent. Very, very important. Okay. So write the definition of non-metals. Again, there is an exemption always. Keep in mind it. Like metals have exemptions. Like here also. Non-metals are those elements. Non-metals are those elements which do not conduct heat and electricity. But there is an exemption. Anybody can tell? Already people knows, familiar it is. Lower classes you might be studied. There is an exemption, metal which is good conductor of electricity. Anybody? Even non-metal. Electricity and are neither malleable nor ductile. Nobody is remembered. There is a non-metal which will be very good of electricity. Basically, non-metals are poor conductors of electricity, but there is a non-metal who is always is a good conductor of electricity. Okay, so that's fine. Yes. Okay. If you don't know, also I'll teach you. You forgot means always. Yes, pencil. Pencil is made up of something. We used to call it as graphite. So okay, I'll make the exemptions always. Listen. So non-metals are defined. We can say they are actually generally they are poor conductors of electricity as well as heat, and they are neither malleable nor ductile. What do you mean by malleable? Hammering into what? Speak, everybody. Hammering into thin sheets. And ductile means what? Yes, please. Stretching. Yeah, drawn into thin wires. Drawn into thin wires. That is what we used to call as ductile. Am I right or wrong, everybody? Yes, please respond. So that is what. Now, non-metals, all of you remember, they are neither malleable nor ductile, and they do not connect electricity and as well as heat. So always just opposite to the metals. But metals, there is an exemption for every physical state. For non-metals also, they're having every physics exemption. So they are electropositive or electronegative elements, everybody? Yes, please. They are electronegative elements. So they will gain the electrons or they will, what will happen? They will gain or share the electrons. Share the electrons to satisfy the octave rule. So that is what. So examples, non-metals count is very less. So what is the first? If you talk about the non-metal, so there is a metal, there is a non-metal. Without that, no life can exist in this earth. What is the metal in non-metal? Anybody?
Carbon, sir.
Carbon. And there is another metal, non-metal, which is compulsory for our survival. What is that? Phosphorus,
Oxygen.
nitrogen, sulfur, oxygen, okay, chlorine, bromine, these are the etc. we used to call as non-metals. Okay, so in that the most important one we know that oxygen and carbon. So our body is made up of carbon. Neon is a noble gas. Who is saying Manikandan? Neon is a noble gas. It is not a non-metal. Sarya Tambi? Yes. So that is what. So the most important non-metal, which is entire life is made up of that. Anybody can tell? All our body, everything is made up of this. All the living organisms are made up of this non-metal. Anybody? All of you?
Carbon.
Yes. That is only called as what? Carbon. So carbon is a very crucial role. Okay. Very crucial role in our daily life. So carbon is the most important non-metal. Okay. And all the living organisms, our body, our flesh, our blood, everything is made up of what? Yes, please. Carbon only. You take proteins, you take carbohydrates, you take vitamins, you take enzymes, you take RNA, you take DNA. Everything contains what? Everybody. They contains carbon. Understanding? So that is why carbon is most important non-metal in our daily life. Next one. There is another non-metal which is essential for breathing. What is that, everyone?
Oxygen.
Yes, oxygen. So we can say life is not at all possible without oxygen. So that is why without carbon, no manufacturing of body. I'm saying manufacturing means prepare, like grow of body. Without non-metal, there is no surviving of body. So that is why without metals we may be survive, but without non-metals, it is impossible to continue the life. It is impossible. Life does not exist without non-metals. So that is why non-metals constitute the earth, ocean, air, water. Everything is non-metals only in our surroundings, if you see, but their count is very, very less. The number is very less, but the importance is extremely high. Do you understand, all of you? Please respond, all everybody. Clear? So this is what about non-metals. Let us study the physical properties of non-metals. But before going to teach physical properties, so we want to study one thing called as allotrope. Of course, I'll teach you. Okay. Now, so please all of you keep reading physical properties of non-metals. So it's just opposite to the metals, but there is a exemptions here. Do you understand, everybody? Please respond. So physical properties of non-metals. Okay. Now before going to say, I want to say one thing. So remember, these non-metals, they will either gain the electrons or they will what? Everybody. They will speak raw. They will share the electrons. Am I right or wrong? So all of you remember, if they will share the electrons, it is neither positive nor negative. Neither positive or nor negative it is. But if they gain the electrons, definitely it is. What is that, everybody? It is negative ions. Okay. They are only we used to called as what? Speak loudly. We used to called as negative ions. Anions we used to say. Understanding? And sharing of electrons, we used to say what? Neither anion nor cation, or neither positive ion or nor negative ion. Is it okay, Amma? Everybody clear? Dakshri, that is what. So now let us come to the physical properties of metals. So basically, the non-metals have just opposite properties of metals. Understanding? And the non-metals generally existed. Basically, if you take most of the metals are solid in state, but if it comes to the non-metals, their count is very less, but they are existed in all the state. So non-metals are existed in solid state, non-metals are existed in liquid state, non-metals are existed in gaseous state. Clear, everybody? So if you take the one and only metal, non-metal, which is liquid state, anybody can tell at the room temperature? Bromine. So bromine is the one and only non-metal which is at liquid state at the room temperature. Next, if you take it here, solids, anybody can tell what is the examples of solids? Solid example, carbon you can take, sulfur you can take what? Everybody. Other non-metals. Nobody knows, sir. Yes, please. We can make many things correct. Iodine is also a solid non-metal. Gases, anybody? Graphite is also a carbon. Now remember, Amma, now I speak about carbon. Carbon means always you have to speak at least about diamond, and as well as next one is what? Speak loudly. Graphite. If diamond and graphite you don't know, third one also you should learn. That is what? Fullerenes. Another? Fullerenes. Okay, ma? Fullerenes. Diamond, graphite, fullerenes. All are made up of what? Carbon only. All these three are called as pure form of carbon. What is that? Everybody? Pure form of carbon. Okay. Now gaseous metals. We all know gaseous non-metals. Oxygen. Next one is what? Nitrogen. Next one is what? Chlorine. Okay, etc. So the count is very, very less. Now, so let us take what is the main important physical properties. The first physical property, the most important physical property of non-metals is non-metals has generally low density or high density, guys. Anybody can tell? They have low density. Okay. Non-metals have low density. Okay, because they do not closely existed. They are not closely packed. So closely packed means they are loosely packed. So density is actually very, very less. So if you take understanding, so non-metals have very low density. They do not closely packed. So basically they will exist in molecular compounds in which atoms are bonded by. So there is no, you don't know the bond actually. They will basically exist in covalent bonds. So we will study what do you mean by covalent bonds. So just have an idea that. So what is a bond present between non-metals, everybody? Covalent bond, LENT, covalent bond. Basically, the bond present between the non-metals is what, everyone? Covalent or covalent bond. Okay. So what is covalent bond? We'll study the next half of the chapter. Just to remember, the bond present between the non-metals we used to call it as what? Covalent bond, which is actually weak bond. What bond it is? Weak bond. Okay. So that is what you have to remember. Now, you remember this always, if you notice, exemption is there. So what is the exemption? All of you? Any exception? Anybody can tell? Example, diamond. So diamond, and if you take graphite, basically they have high densities. Both are, I told you just now, pure form of what? They are pure form of what? All of you, carbon. So exception, they have little high densities. Compared, all the non-metals have low densities, exception, diamond and graphite. So there will be a little high density for them. Okay. Next, all of you, they have low boiling point or high boiling point. Everybody, they have commonly, they have low boiling and melting points. So if you take all the metals have extremely high boiling and melting points, but non-metals very, very low boiling point. So again, what is the reason? Anybody can tell? Due to the strong force of attraction or weak force of attraction? Everybody. Due to the presence of,
Weak force of attraction.
due to the presence of weak force of attraction between the particles. Understanding among the molecules. So because of weak force of attractions among the molecules, they are actually having low boiling point and melting point. But there is, for example, if you take example, sulfur. So can you tell me what is the sulfur boiling point? Anybody? If you take sulfur boiling point, just 115 degrees Celsius. So it's very normal temperature only it is. So, but exception. What is the exception, everybody? Again, same. Exception is what? Diamond. Understanding? Again, diamond and as well as what? Next one? All of it. Graphite. So, diamond and graphite exception, if you take, which have extremely like metals, high BP and as well as what? High MP. If you take the melting point of diamond, the MP of diamond, understanding, if you have taken, which is basically greater than 3500 degrees Celsius. So it is extremely high like metals. Am I right or wrong? Even tungsten metal 3380 only. But if you take the diamond, more than that. Understand, Pugal, Aswin, Gokul? Yes, please.
Yes, sir.
That is what. So that is what you have to remember. So melting point exception, except diamond and graphite, we can take all the things. Next, third one. There is no non-metal will make sound. Making sound is to called as something. Anybody can tell?
Sonority.
Sonority, sonorousness. So all as they do not produce any specific sound, so they are non-sonorous in nature. All the non-metals, no exception. No exception. Okay, ma? So that is what. So that is what they are all non-sonorous in nature. No specific sound. No specific sound is made by the non-metals. Do you understand, Ra? Please respond, everybody. So that is what you have to remember. Next, fourth one. They are soft enough or they are brittle, they are hard enough? They are soft and as well as brittle in nature. Can you tell me what do you mean by brittle in nature? Anybody?
Easy.
Yes. Easy to break. Easy to break. You can see like our chalk piece. Chalk piece can be break very easily or very strong. More force is required to break a chalk piece. Yes, please. Very, very less force is required to break a chalk piece. Okay. So that is what you have to remember. Brittle. Brittle means easy to break. Okay, ma? So please all of you learn that. Brittle, or we can say embrittlement. Embrittlement is called as same. Embrittlement means easy to break. Okay, all of you. So you remember that. Next, again you can see they will be having exception. What is the exception? Anybody? Again same. There is an exception. Very hardest, more than a metal. The hardest known metal to the human being. That is what? What is that?
Diamond.
Diamond. Okay. So again, diamond is a what? Carbon form of. Understanding? It is the carbon form, purest form of carbon. The one and only non-metal which is hardest known substance. More than a metals. Even we will use this diamond to cuttings, even stones, cutting the metals also. So that is what this we will use it in a drill and as well as cutting tool. The hardest non-metal, more than a metals, which is known to the human, is diamond. So it is a carbon form. Am I right or wrong, everybody? Please respond, all of you. So that is what. Next, they do not have luster. What do you mean by luster, everybody?
Shining, some people.
Shining nature. They do not have any luster. But When the light falls, highest refractive index, physics. Who is having highest refractive index?
Diamond.
Diamond. Okay.
Diamond.
So that is what you have to remember. So they do not have shiny surface. They do not have shiny surface. So they are bright in nature or they are dull in appearance. Everybody. They
Dull
are
in appearance.
dull in appearance. Okay. But if you take exception is there. There is a non-metal called as which will shine like a silver. Anybody can tell? Which will start with I. Yes, please. Iodine and as well as another one is called as diamond. So there is an exception. So except this iodine and diamond, remaining all non-lustrous in nature. But iodine and diamond, they are appears to be what? Everybody. They have what surface, guys? Lustrous surface. Okay. So there is exceptions always. Next. They are very soft in nature, brittle in nature, except carbon. Next. So is it possible to make a thin sheets and is it possible to make thin sheets, everybody? Thin sheets and as well as thin wires? All of you?
No, sir.
Yes, please. No. So they are what? They are non-malleable and non-ductile. Non-malleable and
Wonderful.
non-ductile. So if you hit, what will happen, Ra? They will converting into what? If you hit with a hammer or you try to drain the sheets, what will happen? They'll be converting into powder. Okay, that is what. So basically, one more thing, guys. Most of non-metals, they are actually gases. Okay, so very few non-metals only they are in solid state. So that is what they cannot be drawn into wires, or they cannot be make it into what? Everybody, thin
Sheets.
sheets. So that is what. So if you hammer them, they will be converting into what? Hammered means they will be converted into what?
Powder.
Powder.
So that is what? Example, sulfur. So if you try to hit the sulfur, what will happen? Sulfur is like, we can say sulfur is very, very smooth. So if you try to hit the sulfur is converting into what? Sulfur powder. Okay. So basically you can find sulfur powder even in the market also. Next one. They are poor conductors of heat and electricity, but there is an exemption. Anybody can tell? They are poor conductors of heat and as well as electricity. Anybody? They
Graphite.
are poor conductors of heat and electricity. So they do not connect heat and electricity. Why? Anybody? What is the reason? Anybody can tell? Metals will connect reason I taught you. Now here also non-metal, you tell me the reason. Because options of something. Options of anybody. Yes, please. Options of free electrons. Understanding? So electrons only which is necessary for conducting of electricity. Am I right or wrong? Everybody. Yes, please. That is what. In electricity physics also we study. So which is necessary for conduction of heat and as well as electricity. Okay. But there is an exemption. Anybody can tell?
Graphite.
That is what. So exception. So if you notate it, graphite. So graphite is a what? Everybody. One of the pure form of what? Carbon. Now I will speak everybody. Pure form of carbon. That is why you can see, due to the conducting nature of graphite is extremely good conductor. That is why in chemistry chapter number 1, electrolysis process we will use two rods. Anybody can tell what is the rods we will use? Electrolysis process.
Graphite rod.
Yes. The electrodes.
Graphite
It is
rod.
called as what? Electrodes. That electrodes only we can use it as graphite rod. Understand, Vijay? Graphite
Yes,
rod
sir.
we can say. Okay. So the electrodes which we are using in electrolysis process is basically graphite rods. Understand, Harizeras? Because it is extremely high conductivity of electricity, because graphite has a free electrons. So that is why it is a good conductor of electricity. But if you take diamond is not a good conductor of electricity, but diamond is a good conductor of what? Yes, please. It is a good conductor of electricity. Graphite is a good conductor of electricity, but diamond is not a good conductor of electricity. Diamond is a good conductor of what? Anybody? It is the good conductor of what? All of you. Good
Heat.
conductor of heat. Okay. That is what. So it is heat, diamond is heat, and graphite is electricity. So that is what. Now, so every time we are studying about exception only diamond and graphite, most of the cases. Have you checked it, everybody? All of you? Yes or no? So most of the cases we are studying diamond and graphite is exception. So what they are? We all know that diamond and graphite, I told you, they are the what, everybody? They are the
Pure
pure
form of
form of
carbon.
what? Pure form of carbon. But different structure. The graphite is different physical properties, diamond is different physical property. But both are made up of what? Graphite also made up of something, and diamond also made up of something. What it is? That is what is my question. Everybody. Carbon. Understand? So their chemical formula is same, but the physical structure is not same. Am I right or wrong, everybody? Yes, please respond. That is only called as, we used to say, allotropes. Here you can, everybody. See here, all of you. So whose physical state is different and chemical formula is same. That is only called as, what we used to say, everybody? Yes, please. Allotrope. Okay. So graphite and diamond is called as what? Allotropes of what?
Allotropes of carbon.
Allotropes of carbon. Definition theriyada, please write it. Allotropes. Very important one. Next chapter, carbon and its compounds will study. They can exist in different forms. That is what? Different physical state. Sorry, different physical properties. But what is that? Chemical properties are what? Respond. Different physical properties, but same chemical properties. Clear, everybody? So that is what we used to call as allotropes. What is the examples of allotropes, everybody? Diamond is an allotrope of carbon, is the hardest natural substance known, and it is having very, very high melting and boiling point. We studied or not? What is the boiling melting point of diamond? Everybody? More than 3500, greater than 3500 degree Celsius. Okay. Now, graphite is another allotrope of carbon, which is a good conductor of what? Everybody. Which is a good conductor of? Respond, just now we studied. Okay. Electricity. Even sulfur is having allotropes. Understanding? White sulfur and as well as red sulfur. Okay, everybody. So we can say sulfur is also having allotropy. So what do you mean by allotrope, everybody? And this property is called as allotropy. Allotropy. So what do you mean by allotropy? Everybody speak. Different physical properties, but same what?
Chemical properties.
Same chemical structure or same chemical property. That is what we used to call as allotropy. Everybody clear? All of you?
Yes, sir.
Yeah. Clear, everybody?
Yes, sir.
Yeah.
Yes, sir.
Yes, yes. So this is what about allotropy means. Learn the definition is very, very important, guys. Okay. So please make it. So this is what about the physical properties. So physical properties of non-metals. But you can see here, they are combined here, you can take. So which is the metals, who is at in palm also they'll become melting. Who is the metals? Gallium and cesium are the metals. They are not non-metals, which is having low melting point. And these two metals will melt even if you keep on your palm. And next, iodine is a non-metal, but it is lustrous in nature. Iodine and another one, what I told you. Iodine and diamond. Combine the physical properties of non-metals with the metals. but you people separate it and you can study. Okay. So next, alkali metals like lithium, sodium, potassium, they are soft and they can cut with a knife. Like that, like non-metals. So this is the metals which are example, and they have low densities or high densities. Basically, all the metals have high density, but these alkali metals having what? Low density or high density? Everybody.
Low density.
Low density and
Low
low melting
density.
point. So alkali metals, lithium, sodium, potassium, they are very soft and they can easily cut with a knife, like non-metals. Okay, everybody. So that is what about it you have to remember. So this is all about physical properties of metals and as well as non-metals. Anybody having any doubt, you can ask me now. Let us start chemical properties and then we'll continue the tomorrow's class. So write first chemical property of non-metal. We have a little bit more time, so you can write it. So please all of you write it. Next one, first chemical property of non-metal. So they are electropositive or electronegative. First chemical properties, keep it in, all of you. Chemical properties of non-metals. Chemical properties of non-metals. What is the first one, everybody? They're electropositive or electronegative?
Electronegative element.
They are electronegative. First one, write it. The non-metals are electronegative elements. So they will gain the electrons or they will lose the electrons. Fastly, everybody. They will gain the electrons or they will lose the electrons. All of you, they're having a tendency. What is the tendency, Hari? Tendency to receive the electrons or lose the electrons? Receive the electrons. Understanding? In their valence cell. So that is what we used to called as non-metals. So they acquire a negative charge or positive charge after receiving the electrons. Everybody, they will acquire a negative charge and they are only called as anions or cations. Speak loudly. They are anions. That is what we used to say electronegative in nature. Electronegative in nature. That is the first chemical property. So can you tell me, for example, chlorine? Chlorine, how many electrons is needed? One electron is needed so that it will turns into chlorine ion, chloride ion. Am I right, everybody? Second chapter I told you, no, chloride anion it is. So that is next. Oxygen. Oxygen need how many electrons? Anybody? 2 electrons, so that it will turns into O2 minus. So it is a what ion? Oxygen ion or